Okay, so let's have a look at the dichotomy of waves. So if we have this graph here, what's its function? This is y equals sine x, okay, or sine theta. And we would say that from here to there has a name, and it's called the amplitude, okay, or A for amplitude. Okay. Then we have from here to here is one wavelength. Okay, so one wavelength has its own symbol, and what is it?
It's like that thing. I don't know what it's called.
Okay, and it's this Greek letter, and the letter is called lambda.
Oh yeah.
Yeah, that's right.
Lambda. Okay, so that's one wavelength. So we would say that that this here, that coordinate, would be lambda 0. Okay, because that's a distance lambda. Okay. All right. Then we have, now, if this is sine x, then lambda is equal to,
X.
how long is,
No, it's equal to 1, isn't it? So
I think you're talking about the height there, that's 1, and this is -1, okay? But on a sine graph, if this is the x-axis,
2 pi.
that's 2 pi, isn't it?
Oh yeah.
Or in degrees, how much
360.
is 2 pi? 360. Okay. So depending on whether we're working in degrees or in radians, that's going to be 2 pi or 360. Okay. Now if that's 2 pi, how much is that?
Pi.
That's pi. And where is the maximum then? What's the x value for the maximum?
90.
It's 90 degrees or pi on 2.
Yeah.
Okay, so this is where our fractions really come into play. All right. Now, the crest, okay, so this is called a crest, happens at pi on 2, 1 pi on 2. This would be 2 pi on 2. This is 3 pi on 2, and that's 4 pi on 2. Okay, so we could say this one here is 3 pi on 2. All right. And so long as, and so basically if you can work out, you can find one wavelength, you can break it up into quarters like that. Okay. So then we have what's called a vertical shift. And we know that the height for sine x is 1, so this will be 4 and this will be 2. Okay, my scale's off, but you get the idea. And so now we have the equilibrium has now lifted. This is our equilibrium. Equilibrium, yeah. And it's been shifted upward by 3 units. So this function is now y is equal to sine x at 3. Okay? Alright, so that's a vertical shift. Then we have, yes?
I'm sorry, you're about to explain.
What is it? What was I going to go?
I was going to ask, how do you show the horizontal shift? But
Then we have a horizontal shift. So if I were to shift the sine curve to the left by pi on 2.
But then you get a cosine.
Oh, Kadesh, see?
spoilers.
So there's my sine curve. It's been shifted to the left, and so this graph is y is equal to sine x plus pi on 2. Okay. And so what happens to all these x values is they've now been shifted to the left. Okay. So this one used to be at pi, but it's now over here at pi on 2. And that one used to be 2 pi, it's now at 3 pi on 2. And the trough, it was at 3 pi on 2, it's now at pi. Okay. Now, is the wavelength still 2 pi? Yes. It still is, isn't it? So if I add pi on 2 to 3 pi on 2, I can see that's still 2 pi. Okay? And you guys know that when the graph starts there and finishes here at 2 pi, that is called the cosine graph, cosine x. Okay, so that's a horizontal shift. Also known as the
Cosine graph. How does that mean?
phase shift.
Oh.
Oh, yeah, okay.
So different textbooks use that interchangeably. Alright, so we've got the wavelength, we've got horizontal shift, phase shift, the equilibrium, and we've got vertical shift. Did I write vertical shift? Okay, next thing. Let's say that, let's work over here actually. What's right? So here is the general rule. Y is equal to sine b x plus c plus d. Where A is the amplitude, that's right. Okay. B tells us how many wavelengths there are in a frame 0 to 2 pi. Number of wavelengths within, I should say within, not in, within 2 pi. Within 2 pi. Did I do with? I had the in before. Within 2 pi. Okay. So over here on the sine x graph, how many wavelengths do I have within 2 pi?
1.
I only have 1, and so you can see that the value of b there is 1.
Yeah.
Okay. Then we have c, which is the
Horizontal shift.
a horizontal shift. That's right. I added a value there for c. Okay. Now, so I'll put that in horizontal shift, horizontal or phase shift. Okay. And like all shifts, horizontal shifts in any graph, if you have a positive value there, it shifts left, and if it's negative, it shifts right.
Yeah. That's going to be hard to remember.
Just remember the opposite.
And for some reason, with maths, it's always like that. Okay, so even with statistics, when you say it's negatively skewed, it shifts to the right, and then when you say positively skewed, it shifts left. And then we have D, which is the ooh.
The vertical.
Well, it's
That
a
is
vertical
true.
shift.
That is true. It's the vertical shift, and it tells you where the equilibrium is. That's right. So you're both correct. So this is what we know as the vertical shift, and tells us where the equilibrium lies. We could say it's the equilibrium value. Yeah, very good, Zara. All right. So next thing. Okay. Let's say we have. Let me just check the cameras up too. Let's say that we have a graph like y is equal to sine 3x. What can you tell me about this graph?
That it will be shifted upwards 3.
Negatively
The amplitude
shifted
is 3.
to the
Wrong.
left. To
Wrong.
left. No.
Isn't the amplitude 3?
No.
Oh
it'd be really compressed. There'll
It's
be no wavelength.
compressed.
That's right.
It's the b value,
Oh.
Yeah.
right? It's the coefficient of the x, which is b, and it tells us how many wavelengths there are within 2 pi. There are 3 wavelengths within 2 pi. So instead of doing one big one, I'm going to do 3 little ones. 1, 2, 3. Something to that effect.
Wow.
Okay? Alright, next one.
How many can you fit in there before it turns into a straight line?
Well, if you went 100, then it would just, and you try to graph it electronically, it would really just look like this. Okay. Alright, let's try this one. 2 sine 3x minus 1.
So,
B blank?
The amplitude is 2.
Good.
The wavelength is 3, just as same as the other one.
The wavelength is not
The
3.
It's
The number of wavelengths
within
2
2
pi
pi
is
is
3.
3.
Good.
and it has a horizontal phase of 1.
Ooh, so close.
Negative
Oh,
one.
very
So
close.
close. You said horizontal, and it's not a horizontal shift.
it's vertical.
It's vertical, so
It's a vertical shift
Is
of
it?
down 1.
It's going down.
Okay, so watch this. That would be a horizontal shift of 1.
Oh, okay, yeah.
And that is now a 0 horizontal shift and a vertical shift of -1. Okay? Good thing we're doing this. So if the equilibrium is now at -1, there, and the amplitude is 2, I'm not going up to there anymore. I've doubled it, so I'm going up to 1. Okay? So I need to go down as low as -3, don't I? Okay,
Yeah.
so here's my equilibrium, and it's doubled. So it's doubled going up, but it's also doubled going down.
You have to fit in 3, so.
Have to fit in 3. All right, 2 pi on 3. There you go.
Okay.
That works too. Otherwise, I would do 3, and it would be 2 pi out here. Yeah. Okay, let's try another one. Let's work back over here now. Zara, pick for me a amplitude.
2. -2.
-2. Excellent. Okay. Alright, so here's my graph. What's it going to look like?
It'll just be like a normal sine graph, just with a taller like a higher amplitude.
Okay, so there's 2 and here's -2. So you're saying it's going to look like this.
Isn't that just an
Have we
amplitude of
flipped
2?
Oh no, but it's -2, you're right.
Right. So this graph is 2 sine x. The negative means there's a reflection this way.
Oh, cool.
Okay. Oh, thank you.
Yeah, that was.
My y-axis is a little crooked though, isn't it? All right. Last one before we go. Here we go. Let's go 3 sine x minus pi plus 1.
Oh.
Amplitude is 3.
Good. Now, we really should start with the equilibrium.
Oh,
Start with the vertical shift. So it's 1, right?
Yeah.
Okay, so here's 1. Now we go to the amplitude. How far up do I go?
4.
I go to 4.
Mm.
How far down do I go?
2.
2. Yeah, -2.
Okay. Good. So I might just dot in.
You need to go pi.
I might just dot that in like so.
Mm-hmm.
And that's 2 pi, isn't it? That's 2 pi there.
Does that mean you have to skip
But it's
the negative
to
pi?
the
is
Just
right.
shift it.
I need to shift it to the right by
pi.
a distance of pi.
So by a
So half
radian?
of that.
So that's 2 pi. Here's pi. I need to shift everything that much.
Yeah.
Okay. So there's pi, 2 pi, 3 pi is here. that coordinate is now here.
Yeah.
And this coordinate, the starting coordinate, is now here.
Yeah.
Cool.
Now, I think I was meant to go, not there, I was meant to go through there. Yes, I was meant to go through there. Down to -2. Something like that.
Alright.
Okay, so that coordinate is now there, this coordinate is now here. That coordinate is, which is halfway between 0 and pi.
Between pi
Right.
and 2 pi.
Yeah.
So that is now halfway between here.
3 pi.
And this one, which is halfway between those two, is now halfway between there. Okay, so we get this curve.
Yeah.
Okay, more or less. Okay, so very good. So that's most of it. We haven't gone through frequency and solving for the wavelength yet, so we'll do that next time.
So,
Gilly, what?
this, can you use the sine